Alright, let's continue exploring the issues with subject models. For example, when should I use subject models? And the model seems to have many different ways of doing things. How should I build the structure of these models? Which ones can be built? Which ones cannot be built? Right, let's take it one by one. Because, in fact, there are various kinds of model structures, so here we've listed a few recommendations from us as official guidelines. When facing similar scenarios, we can realize when to use a model and what kind of model structure we should establish. Our first recommendation is that when there are multiple dimension tables with different granularities, we recommend using models and trying to construct something called a new model. Don't rush, let's go one by one. What are multiple dimension tables with different granularities? As mentioned earlier, different granularities refer to things like department, region, time, and product dimension tables. These tables are at different granularities. If you want to join them, you will definitely encounter issues like duplication and redundancy. This is the first point. When there are multiple dimension tables with different granularities, we should use a model and try to build a new type of model. Now, what is a star schema? A star schema is a structure like the one shown in the image. In the middle is a fact table that records specific information, data, and indicators. For example, a sales fact table records sales quantity and sales amount. Then, we establish relationships using dimension tables, wrapping them up to form a star shape. In this case, if we want to analyze the sales quantity and amount of different products, we only need to drag the product name from the product dimension table and the sales quantity and amount from the sales fact table to get the results. No need to do any joining because the model already sets up these relationships. An extension of the star schema is the snowflake schema. The snowflake schema is not particularly complex. The left side is actually the same as the star schema. Its special feature is that it allows further drilling down, like adding country, province, and city dimensions to the region dimension. What does this mean? Let's say we want to expand some cities. In the past, merging data might require us to do some data editing and updates. But now, we only need to maintain the city dimension table. Once that's done, there are no issues with the data. This is one of the advantages of the model. That's the first recommendation. When you see such a structure in your business tables, try to use models and establish a new type of model. The query efficiency of this new model is very high. The second recommendation is that when there are multiple dimension tables at the same granularity and we need to associate multiple fact tables, we suggest joining the dimension tables first and then associating them. This might sound a bit abstract, but let's look at a specific example. What does it mean? It means the same granularity, like product. But maybe the product name and brand are in one table, and the product category and subdivision are in another. But these two tables are actually at the same granularity, both about products. Our recommendation is to join these two tables into one product dimension table. Once we have that, we can establish a 1N relationship with sales fact tables, stock fact tables. Then we can analyze the sales, stock data of different products. That's the second recommendation. When you face this situation, you need to do this kind of processing. The third recommendation is a little more abstract, but don't worry, I will break it down for you step by step. The third recommendation is that when the relationship between tables is N to N, many to many, and one fact table contains the complete set of all shared dimensions, you can directly do an N-to-N association. What does this mean? Let's look at an example. It's about associating the pre-sales fact table and return fact table in an end-to-end relationship. What is meant by the complete set of shared dimensions? Let's assume a business scenario. Regardless of whether a product has return records, it must first be recorded in our pre-sales fact table. This means the product will be in the pre-sales fact table before it appears in the return fact table. In this case, the product name and category in the pre-sales fact table form a complete set of shared dimensions. When analyzing, we can drag the product name and category from the pre-sales fact table and then drag the sales amount and return quantity to analyze the sales and return situation for different products. This covers the first part of our sentence. What about otherwise? Otherwise means the condition is not met. This means that the product name and category in both the pre-sales fact table and return fact table are not complete. However, by combining the fields from both tables, we form a complete shared dimension. In this case, we recommend avoiding a direct end-to-end association because the analysis might not yield the expected results. Instead, you should first extract the product name and category from the pre-sales fact table, then combine it with the product name, category, and other product-related dimensions from the return fact table. Once this product dimension table is created, join it and perform a one-to-n, one-to-many association with the pre-sales fact table and return fact table. After this, you can proceed with your analysis. So, this is how we handle the overall usage of the model, which models are supported, and our recommendations for their use. Alright, let's summarize this part. Let's summarize the value of the subject model today. It helps everyone to understand the subject model from a more global perspective and what this feature means in future analysis. First, the model makes the system much more powerful. Okay, in the past, when we didn't have models, all the operations were done in data integration. We joined data, whether vertically or horizontally, and did group summaries. All of this was editing our raw data. After editing, we would generate a new table. Based on this new, wider table, we would perform further analysis, dragging the included indicators and dimensions. This was our previous approach. The downside, as we mentioned earlier, has been explained. Now, with the model, the entire structure of the product has actually changed. We can see that the data editing stage is split into two layers. The first is the model's view layer, which is the model view in the functionality, and the second is the data layer that you are familiar with. In the model view layer, we don't handle the specific content of a table. Instead, we establish relationships between tables. Once the relationships are established, we won't generate a large, wide table, but instead, based on the dimensions and indicators you drag, a new logical representation diagram is generated. This logical table is essentially the table we just saw, aggregated and then joined. Depending on the analysis questions or the dimensions and indicators dragged, it might be adjusted further. For instance, it might be generated on a timed basis, rather than being a real, large wide table. You can think of this conceptually. Then, based on this logical view of the table, we continue with visualizations, OLAP analysis, quick calculations, and advanced calculations. Moreover, with the model, the whole component system is connected. You will find that the fields we use in the analysis area can be reused across different components. In the past, each component was separate and independent. Now, with the model, it helps everyone reuse these fields, especially fields across tables, which can be used in different components. All of this is possible because we have the subject model feature. Now, let's talk about what the model does for business users. It simplifies data analysis with many tables. Through the model, we can reduce the complexity of data processing in the early stages. In the past, we might need to copy many tables, create many intermediate tables, and do a lot of editing and processing, often altering the original table structure. Now, we don't need to do any of that. We only need to establish relationships in the model to start the analysis. Additionally, we provide a more flexible and efficient multi-table joint analysis approach. Just like before, many operations in the current model system no longer need to be done. We just configure the relationships, and by dragging the fields, everything is done. Finally, for IT or more technically focused users, this is important. The model reduces the number of large, wide tables, alleviates data redundancy, and improves the overall data calculation performance.